Moving on with finding zeros of polynomials, we are working through an example of this degree 4 polynomial. We know that we should be finding 4 zeros total. Our calculator and our rational zeros theorem told us that -7/3 and +9/4 are zeros. So let's confirm that these are our rational zeros, and let's see how this helps us to figure out what our other zeros are. So again, the calculator told us that -7/3 and 9/4 are actual zeros. So let's use our synthetic division to confirm that these are actual zeros. I'm pulling my coefficients down. I am not missing any coefficients, so I don't have to fill in with any zeros. And then I can divide by either one of these here. It doesn't matter which one you choose first, both of them will work. So let me use 9/4. I just randomly picked one. If you would have picked -7/3, it would have worked out the same way. So bringing down my first number of 12, now multiplying. 12 divided by 4 is 3, so 3 times 9 gives me 27. So when I add 27 and 1, that gives me 28. So now I multiply. 28 divided by 4 is 7. When I multiply that by 9, that gives me 63. And when I add -51 and 63, that gives me 12. Multiply again, I know that works out to be 27. Add 28, multiply gives me 63. And so when I add these, I get a remainder of 0, which I knew I should because my calculator told me so. Okay, so what I just did was I factored this polynomial by one step. So I factored it as x minus my 0 of 9/4, and then my remaining coefficients down here, starting 1 degree less. So this was x to the 4th, so this gives me 12x to the 3rd plus 28x plus 12 plus 28. So now I want to continue factoring it using the methods that we know how. So if I look at this here, if I factor it now, I can pull out a common factor of 4. So I have x minus 9/4 times 4. And then if I take that out, that leaves me with 3x to the 3rd plus 7x squared, which I lost, plus 3x plus 7. Now, we don't typically keep our factors like this. We don't usually see fractions in them. So the nice thing about factoring this 4 out is I can distribute it through there, and then I won't have that fraction in there. So 4 times x gives me 4x, and then -9/4 times 4 gives me -9. So now what I need to do is I need to factor this piece over here a little bit farther. Now, I can factor it using my old school methods, using factor by grouping, or I can factor it using synthetic division. It doesn't matter. Either one is going to work out okay. I think that our old factoring techniques are probably a little bit easier. So let me group this up. So there's my two groups. So if I take out a common factor of my first group of x squared, that leaves me with 3x plus 7. Taking out a common factor of just 1 in my second group of 3x plus 7. And now factoring out my 3x plus 7. And that leaves me with x squared plus 1. Copying down my factor of 4x minus 9. So I have factored it here. Okay, so I'm getting really close to my answer here. First, it asked to find the rational zeros, and I knew that I had 2 of these because the calculator and my rational zeros told me so. So my rational zeros are given by this one, x equals positive 9/4, and this one here, x equals -7/3. So those are my rational zeros. Now this one here is going to give me my other zeros. So what I need to do then is I need to set that equal to 0. So what happens when I set x squared plus 1 equal 0? If I move 1 to the other side, that gives me x squared is equal to -1. Force in my square roots to get rid of my square, which forces in my plus or minus. And that tells me that x is equal to positive or negative square root of -1, which we know as I. So that means my other zeros are, in fact, imaginary numbers. And that explains why we didn't see them on our graph. So we knew that we should have 4 zeros total. When we looked at our graph, we only saw 2 of them. And that was because our other 2 are imaginary. So if you don't ever see zeros, it's most likely because they are imaginary, or the possibility that you aren't zoomed out far enough, but most likely it's going to be imaginary. Okay, so now our second part of this problem asked us to find all the zeros. Well, our rational zeros were the -7/3 and the 9/4, and then the other zeros happen to be positive I and negative I. So let me kind of address these a little bit more. Anytime it asks for rational zeros, those are zeros that are either going to be whole numbers or fractions. And those are ones that will show up in the rational zeros theorem. When we write out the list of possibilities, like here in the red box, those are the only ones that are going to show up to be rational ones. When it asks for other zeros, those are the ones that are going to take other formats. So for example, what we see here, imaginary ones, or like when we saw in our last example, we saw square roots. So those are the only possibilities to come up with other zeros. Now you should know what these are by what the graph tells you. So if they are not shown up on the graph, then that means they're going to be imaginary if we don't see them on the graph. Like this example that we saw here. We know that we should be seeing 4 of them, but we only saw 2. Now when you have square roots as answers, you're going to see these on the graph, but they don't match up with your rational zeros theorem. So they don't match up with the fractions that you have listed out with my rational zeros theorem. And an example of that was our first example, which was this one here. We had 3 zeros, but only one of them matched up with the list of possibilities that we had down there. So the only rational zero we found was this one right here, and that happens to be the 2/5 one. But we also had zeros out here, but they did not match up with our list of numbers. So that means that had to be some other form of the zero. And so when we see things that happen like that, that means they're going to be square root answers. So immediately, as soon as you graph these things, you should know exactly what type of answers you're going to have. If you see fractions or whole numbers, they should match up with the list of numbers that you write out in your rational zeros theorem. If you see other answers that don't match up with the rational zeros theorem, that means they're going to be square roots. And if you don't see other answers, that means they're going to be imaginary numbers. So the graph should tell you exactly what type of answers you're going to look for right away. And then when you get your answers, make sure that they confirm with what the graph told you in the first place. Okay, so we found all of the zeros here, and now what we wanted to do in part C is we wanted to factor these in linear factors. Now we did a lot of this work previously, so we had this done here. We factored it into this factor, okay, but now we need to factor this piece a little bit farther because it's not linear, it's degree 2. So I'm going to factor it in the knowledge of if this is a 0, then x minus this is a factor. So I have my 2 factors of 4x minus 9 and 3x plus 7, and then x minus I is a factor and x plus I is a factor. So if we were to multiply this out completely, that should give us the polynomial that we started with. So we finished up this example here, and in the next video, we're going to be talking about some other things that we learned about zeros of polynomials.